Linux directory structure a little bit. Let's take a quick little tour. If we do a listing in the top level directory, you'll see a whole bunch of subdirectories here. Now, a lot of these subdirectories are on every single Linux computer that you'll come across. And furthermore, the meaning and the contents of these directories is practically identical from system to system. So let's look at the most important of these directories. The bin directory, in that directory are important binary executables. The ls command, for instance, the executable version of that command is in the bin directory. The copy command, the vi command, they're all in the bin directory. The boot directory is stuff that we need to boot the system. The Linux kernel image, some config files are in the boot directory. The dev directory we've seen holds one file for every device on the system. The etc directory is for system configuration files. /home under that is where the user's home directories are located. The lib directory is for shared program libraries. A lot of commands and utilities in the Linux system, they share some common code, and that common code is in the lib directory. The mount directory is where we mount removable media, things like CD-ROMs and floppies. The op directory is where we would install optional software. So if you had some prepackaged game or spreadsheet that you wanted to install, you would do that in the op directory. The proc directory is where we store information on processes on the system. We'll talk a lot more about that in some other nugget, so we'll just leave it at that for now. Under the root directory is the root user's home directory. System administration utilities are in the sbin directory. /temp is just for temporary storage. Any user can write to the temp directory. The var directory is for variable data, things like log files or users' mail directories, things that change over time. And finally, the user directory. This is a vast directory, and we'll talk about this carefully. When I first learned about the user directory, I learned it stood for user-specific resources. And I think that meaning has kind of eroded over time. But let's go into the user directory, and I'll try to explain what I'm talking about. So we'll go into the user directory, and we'll do a listing in there. And one of the things I want you to see is that there are some subdirectories of the user directory, like user bin, and user etc, and user sbin, that have a corresponding partner one level higher with the exact same name. So the /sbin directory, we learned that directory has system administration utilities. Well, the user sbin directory also holds system administration utilities, but it holds those utilities that are specific to user administration. So the classic example would be that the user sbin directory holds things like the user add and the user delete commands because they're user-specific system administration utilities. Okay, and remember the idea of the user directory here is for user-specific resources. So now, the user bin directory, though, this is why I say the user-specific resources nature of this directory is kind of washed away or been massaged a little bit. The user bin directory doesn't really hold executables that are user-specific, really. It just holds stuff that's really not quite as critical to using the system as the /bin directory. We saw the /bin directory held like the ls command and the cd command and the more command and the move command and stuff that is critical to using the system. The user bin directory holds stuff like the clear command to clear the screen and some C compilers, stuff like that, that is not quite as critical to using the system. Now there are some subdirectories of the user directory, like user include, user local, that do not have corresponding directories one level higher. The user include directory, that's if you want to include some particular function in a C program, you would include that from the user include directory. The user local directory would be stuff that's local to this particular machine. If we had a networked system here, all these directories we could set up to be shared across all the computers in the network. Then the user local directory would be local to this particular machine. So if I installed something in user local, then that would not be visible to any other machine on the network. And maybe I want it that way because it's some experimental thing or it's something I'm developing and I don't want everyone to be able to use it yet. Now let's move on and talk about security in our Linux system. First we're going to talk about the security of accounts and passwords, and then we're going to talk about the security of file systems and programs. And finally we'll talk about what's called set UID permissions. These are really important to understand, so we'll talk about those carefully at the end. Now in terms of accounts and passwords, the two things that you can do as a system administrator are remove dormant accounts and get users to pick good passwords. Okay? Dormant accounts are accounts that are no longer used, or perhaps they're accounts that have never been used. At a university I used to teach at, the students would sign up for a class and get an account, but then they drop the class before the first day, and their account would just sit there the whole semester. Okay? This is a way in for people, the dormant accounts, because if somebody cracked into a dormant account and changed the password so they could repeatedly get onto the system, the person that owns the account would never even know because they don't ever log in, so they wouldn't even know that their password's been changed. And then the other thing you have to do as a system administrator is get users to pick good passwords. How do you do this, you might ask? One word: education. You have to explain to users what a good password is and why it's important to pick good passwords. So you might be wondering yourself, what is a good password? Well, here's a good example of a password. Great Scott. Okay, maybe I use the number 8 and the number 0 in there in capital and lowercase letters, and so I've mixed it up, and that's a pretty good word. What's a bad password? Something like baseball. Okay, this is a bad password because it's a word in the dictionary. At a university I used to go to school at, a professor every semester would go around and he wrote a program that would go through all the words in the dictionary and try every one of those words for everybody's account. It would take about one night. You know, he'd start it at like 10 o'clock at night. It would be done at 8 in the morning or something. And this would try to crack into everybody's account in the system with every word in the dictionary. Now, the surprising fact of this was that he got into over 1/3 of the accounts every semester practically. And that's because people were using bad passwords like baseball or a pet name like Brandy or Rover or something like that. And these are all words in the dictionary. So no good. These are bad passwords. So like I said, get users to mix uppercase and lowercase letters, put some numbers in there, some punctuation marks, things like that. In terms of security of file systems and programs, the things that you can do as a system administrator, one is remove unnecessary programs. If there's some program on your system that's sitting there that's executable by everybody, but you don't know what it is, it's not part of the regular installation, nobody seems to take responsibility for it, things like that, then you should definitely get rid of that program. Because what it could be is it could be some sort of a backdoor into your system. Maybe somebody cracked in and got the root password once, and instead of changing the root password, which you would notice probably the next day, what they might have done was put this program in place that could give them root privileges if they ran it. Now, so you want to remove unnecessary programs. Don't just go around and remove every program that you don't know what it does. If it's part of the regular installation, it's probably okay. And then the other thing you want to keep track of are users' permissions for each other's files. The default permissions are set by what's called a umask value. This umask value is set in the Etsy profile file. And if you do a umask with a capital S option, if you just type this command, you'll see what your default permissions are. And for most Linux systems, there's something like this. Read, write, and execute for the user, read and execute for the group, and read and execute for others. In some Linux systems, it might be just read and execute for the group and no permissions for the others. Okay, so you can set that, like I said, in the Etsy profile file. And you can examine it with this command. And the important thing, like I said, is that you don't want to have this be too liberal. You certainly don't want like read and write execute for group and others, right? Because then they could just go in and delete files at will. So you certainly want read permissions or read and execute permissions and less. You never want more than this as the default set of permissions for a file. Now I want to talk about those setuid permissions. I want to talk about what they are and also how you can identify when they're being used. So the first thing I want to do is I want to look at the Etsy shadow file for this discussion. Remember, this is the file where people's encrypted passwords are stored. So let's look at Perry's password here. And forget the $1, all the passwords start that way. What I want to look at is the next few letters, 3FOT. I think that's actually a 0 too. 3FU0T. Okay, just remember those few characters. Then what I want to do is I want to look at the permissions on the Etsy shadow file. Okay? So here, when we look at these permissions, you can see that it's readable by root and has no permissions for anybody else on the system. Okay? Now I want to quit being the root user. I'm going to exit out, and now you can see I'm back being the Perry user. Now what I want to do is I want to change my password as the Perry user with the password command. So it says, what's your current Unix password? So I type that in, and now it says, what's your new password? Okay, so I'll type my new password in, and I'll retype my new password. And now it says, okay, everything's been updated successfully. Now I want to switch back and be the root user again. Okay, so now I'm the root user again. And what I want to do is I want to look at the Etsy shadow file again. Remember, the first few characters of Perry's encrypted password was 3FU0T. Okay, now I want to look at the Etsy shadow file again. Now if you look at Perry's password, the first few letters are ST8E7. It's different. right? It's different than it used to be, but Perry doesn't have any write privileges to this file. In fact, he doesn't even have any read privileges to this file, as we saw before. Nobody on the system has any read privileges to this file at all, but yet somehow Perry changed this file by running the password.